Hi, hello, and welcome to UPSC with VAR. Good morning, good afternoon, and good evening from whenever you're seeing it. So, the first topic for today is net neutrality. We'll see basic four topics which are very easy, and by tomorrow, we'll complete all the emerging technologies, all our small topics. It's taking time to generate the workbook for your emerging technologies. So, that's the reason for delay. Come, let's see what's net neutrality. So, first, let's understand what's neutrality. That is neutral. You should not take any side. You have to be balanced while giving something to anybody. That's what it said. Even in our schools, it is said that teachers being partial to that student, this student. But being a teacher, she or he has to be neutral to all of the students. That's what net neutrality also suggests here. Net is nothing but the internet which you use. So the internet has to be neutral to everybody. But whom it has to be neutral? That's the question. It has to be neutral for the content websites and platforms. So, for suppose this is an internet fellow, he handles all the internet. Now, Netflix will come to him and say, if somebody is clicking Netflix on your IP address, uh, I mean, in the internet service provided network, first you give preference to Netflix only. If somebody comes and says, okay, if somebody is clicking Google, give them the preference so that we'll pay you extra money. So, what happens this way is maybe if he's giving more preference to Netflix and less preference to, suppose, say, VAR website. So, what happens is when you click VAR website, it takes longer to load rather than Netflix because Netflix is paying a huge amount to the service provider. Okay, so what happens here? I am getting the effect. I am being discriminated because I am not paying an extra fee, right? So just like the premium services, like even in your Netflix, Hotstar, you have your premium services. In the same sense, the Netflix is coming and asking this guy, okay, please give me the premium advantage and all. In order to facilitate neutrality between all of them, the concept of net neutrality came into existence. That is, you have to treat all internet communications equally without discriminating or charging differently based on content, website, platform, or application or user. So, what happens from here? Equal access to all online content. So, there will be no prioritizing or no blocking of specific websites or services based on the priority scheme. What is the importance? It will give the users, the end users like me and you, that our choice and freedom, because everybody doesn't have a Netflix account, everybody doesn't have access to premium accounts, right? So this way we get our choice correctly, and then it will encourage innovation and fair competition, because if this neutrality does not exist, companies will tend to pay more and more, which will hinder startups, because startups can come but they cannot pay much amount to the internet guy, right? So this is basically the net neutrality. We'll see the difference between what is net neutrality and content delivery network. So content delivery network is nothing but a server which produces images or videos, etc., from its database. So, for suppose you're here and now you googled something. So, here is your internet service provider. So, you googled something. So, Google's headquarters is in US. So, do you think whenever you Google, the internet service provider makes sure he goes to Google headquarters, get back your information? This doesn't happen, right? So, what these big companies actually do is they set up servers every here and there. They will have a distribution of servers which is connected to the main server. So, whenever you Google something, the first thing which goes to the service provider, from there it goes to these content delivery networks. where you have your images or whatever you have searched for. Mostly you'll get the information from here. So what happens here is the time delay is less. That is the latency. That is the search and the result rate is called, the time difference is called latency. So this decreases. But yeah, it's not like it will never go to the Google server, but if in case you search something which is not there here but it would be, then it could go contact your headquarters and come back. Okay, so that is what CDN is, content delivery networks. So every website, I mean, global websites can have their content delivery networks in order to promote their efficiency. See, that's what content delivery is. Systems that distribute content efficiently by placing data closer to users for faster access. Impact on net neutrality. See, here the basic difference I would like to tell you is net neutrality is the internet. So internet has to not divide that, Netflix should come first, Google should come first. It should not divide anything like that. But it has a option of dividing it like that if the provider wants to. So that is the reason we have stopped. We have put net neutrality for here. But what is content delivery network? So content is placed here. There is no uh, superiority or inferiority in the content. Content can be anything. Anybody who searches, it will come to the content delivery networks and it will take the information. So it's not that there is prioritizing of information there. So the net neutrality does not apply to the content delivery networks. Okay. Next, do we have any policies for net neutrality? So India supports net neutrality with TRAI regulations, that is Telecom Regulation Authority of India has put some regulations for this net neutrality. That is, ISPs, Internet Service Providers, cannot block or they cannot block the content. There's no preferential treatment to specific content providers. As I was telling, Netflix or Google, they can give more money and tell, okay, please access our content first, like that. That won't happen. But what is our current challenges? We have huge amount of internet service provider, and also with the emerging technologies like 5G, AI, everything. So making sure and taking back all the information is like little crucial right now. But going forward, we'll find solutions for them as well. So this is what net neutrality is. Just remember what's net neutrality, and yeah. So in net neutrality, I forgot to tell you two more conditions. I think I did not include it in the slide. So the CDN is not included in these regulations because CDN is totally a different issue with comparison to the net neutrality. And the other thing is, generally internet service providers do not uh, facilitate uh, the partiality, but sometimes during the disasters or something like that, it can be applied. Okay, come on. Next, we'll go to what's Web 3.0. So, what's Web 3.0? Before saying that, we'll understand what's Web 1.0, Web 2.0, and Web 3.0. Right now, we are in Web 3.0. We are using 2.0 as well, but we are in Web 3.0. So earlier, like in 1990s and early 2000s, just imagine Google. That is where you'll understand mostly. So it was only static, read only. Now you'll go to Google and you'll type something, you'll get the information. You can just read it. You cannot edit all the content of somebody else. Okay? So let's take example of Wikipedia. So Wikipedia is a centralized system. You can just read it, but you cannot edit it. Maybe you can give some suggestions, but no. Okay? So it's hosted on servers. A guy in the central who is actually the owner will keep their servers and the content would be retrieved from there. and technologies. It's not important, but just remember the HTML and HTTP technologies are being used here. And coming to Web 2.0, that is, it became a little interactive from mid 2000s to present, like the most famous Facebook or right now the Instagram. All of these are web where you interact. Even these are centralized platforms, okay? And the platforms own their data. They are interactive. We are still using them. Coming to what's next. Next is this decentralized web. What's decentralized? So, as we spoke in the last class about the blockchain technology, you'll have different blocks where everything is interconnected and there's no centralized system. Users own and control the data. There will be no central authority to do anything. Challenges can come to the government, but they will do it in the way forwards, when problem comes, they'll think and a solution will obviously be found, okay? So web 3.0 is nothing but managing all these, like these web 2.0 in a decentralized format where you own your own data, see, of the internet, focusing on decentralization, blockchain technology, and artificial intelligence. So, what are the okay, we have another emerging technology which will emerge in the future, not right now, but it's said that they'll come in the future. So, what's Web 4.0? It's an interactive web where, suppose, for example, your groceries are over, or else you have ordered groceries 1 week back. Then, what actually the system does is it will initiate a request saying that, it's been 1 week, I think the vegetables are over, or else they might be rotten, so it's time to order a new thing, okay, right now. And they might order as well. So this is an interactive, like they will also start interacting with us, they'll understand our needs, and they'll make sure you don't feel, sometimes it happens, you forget things, it won't forget. And coming to Web 5.0, this is an emotional web where the web itself starts connecting with you emotionally. This is a full way forward, we'll see what's for us in the future, okay? And yeah, as I told, it's decentralized. It was powered by blockchain and peer-to-peer networks, as we've already spoken. So you'll have machine learning, and you use your own data, and it is yeah, smart contracts. As I told, you can initiate your own applications whenever you try to do proof of work or proof of stake, as said. So you'll have no intermediaries, but yeah, it's trustless system because we do not know who is paying, we do not know who is taking, because it's totally decentralized, okay? Next, core technologies, as I told, blockchain, smart contracts, artificial intelligence will also be there. Decentralized storage, because there's no point of truth or no point of failure, as we have spoken. And cryptocurrencies, transactions can be done through this, but it's decentralized. Coming to advantages, privacy and security, and there will be control of your data and ownership. Transparency will be there in your transactions, and there will be new opportunities because it's decentralized. But what are the challenges? It's very hard to implement all of these because it's totally different, AI, blockchain, as we've seen, smart contracts, decentralized storage, all of these are very new terms, and inculcating all of them together is a bit difficult. So, regulatory concerns and governance, scalability issues, and then higher initial costs. So, these are the advantages and challenges for Web 3.0. So, I think you understand the concept nicely. So, the next we are seeing about the supercomputers. What is a supercomputer? Just like as we were talking about quantum computing and everything, supercomputers process data very, very fastly, calculations very, very fastly. So the normal our computer, if it's taking some for a very big calculation, it might take 10 days. The supercomputers can take it in maybe 1 to 2 minutes. That's how fast they are. Okay. So a supercomputer is highly advanced computing system for performing billions to trillions of calculations per second, often used in scientific and engineering challenges. So to people like me, who I am not doing any scientific calculations on computers right now, so do people like me really need supercomputers? The answer is a complete no. The systems which we use for daily use, it is super. Just because for advancement and technological researchers, these computers are beneficial. Okay. So coming to India's supercomputers, Param City AI. It's among the top global supercomputers. So and then we also have Pratyush and Mihir, which is dedicated to weather forecasting and climate research. So world's best supercomputer is Frontier from USA, and this is from Japan, and this is from again USA. So before understanding, we have to understand a little technical term, but very easily. Do not remember everything. For just I'm telling you for your key reference. So megabytes per second. So what our traditional laptops or systems actually do calculations is, it will transfer megabytes per second. So I'm telling you byte is actually 8 bits. What's a bit? 1 bit is equal to 0 or 1. So like that, it's megabits per second. Coming to supercomputers, it's flops, floating point operation per second. So it will actually do millions and trillions of bits per second. Okay. So now we measure supercomputers with flops. So it's measured in flops, indicating their ability to handle complex calculations. And if there's a more advanced supercomputer, it can also be calculated in petaflops, exaflops, like that. Okay. So these traditional computers, as we are telling, it is measured based on speed and data transfer. That is why we are seeing in megabytes per second. But whereas when you come to supercomputers, it's calculated on computational power. That is why we are seeing floating point operation per second. Okay. So coming to applications, as I told, it's for scientific research, artificial intelligence, healthcare, defense, engineering, and industry. We have something called National Supercomputing Machine, which was launched in 2015 by Ministry of IT and Department of Science and Technology. So what's its objective? We need to prepare indigenous supercomputing capabilities, okay, and establish 70 plus supercomputers across India for academics, for research and industry. Coming to what progress did we do? We deployed the Param series computers and creation of as we told, we have supercomputers for weather forecasting, healthcare, and AI research. Coming to future goals, it is like, as I told you, flop, petaflop, exaflop. So we need to achieve exaflop computing by 2028, and we also should decrease our imports. Our main highlight should be indigenous supercomputers preparation. Coming to the challenges, see, you should have a big hardware setup which is of high cost, and as the computational speed is increasing, you also know that the energy consumption will also increase. And coming to the technological gaps, right now we want everything indigenous. This is what our machine is actually saying, but we have a lot of technological gaps. Even in AI or else in quantum, we are still learning what has to be done. So there are technological gaps and shortage of skill force. We need to have more people learning all these concepts so that it is better understood and better worked upon. And then we do not have proper regulatory and security concerns right now. So what can be the way forward is like we need to promote more research on quantum computing and AI enhanced systems. And as energy consumption is more, we need to put more energy efficient hardware and softwares. And we also have to strengthen in international collaboration. And lastly, we are going to see the satellite based internet connection. Before going all of this, we'll see this. Okay. Normally, what's satellite based communication? So whenever you send a message, it will go to a tower. From there, it will search another tower, other tower, other tower, because you send the message somewhere very far. So it will take the towers and it will come to the other person, the message, which is like a long process where if there's a climate disturbance or there's a flood, there's no way you can reach to this person, right? Until the network is put in place. And going to rural areas, you totally forget about it because all of these connections are set up in the urban areas mostly. In rural areas, also, we are integrating into it, but there are many rural areas till date which do not have these connected connections even till today. Okay, so what happens here is now you send a message and the link will directly go to the satellite, and then this communication satellite will search that person, either send it to that person or it will send it to the nearest satellite center where it will go to this person. This is how satellite based communication and internet works. That is uses the orbiting satellites to transmit and receive data for telecommunication, broadcasting, and internet services. So data is transmitted from a ground station to a satellite in an orbit. The satellite relays the data to another ground station or directly to the users, as I told. So you'll send a message, it can go directly and come directly, or else it will from here it will go to a ground station. From there it will go directly to the satellite and directly here. So what happens here is it will eliminate all these one by one connection and going to that person. So what kinds of satellites can we use? So as we know, this is Earth and we have Leo, MEO, and GEO, that is geostationary orbit, medium Earth orbit, and low Earth orbit. So you can actually use any of them, but more, this thing is for geostationary Earth orbit, because for the whole Earth, 3 satellites are enough to cover the whole Earth. So this is your most potent or very nice solution, but it's a very costly issue because it's, see, geostationary, because its fixed position covers largest area. We can use it for TV broadcasting. Coming to medium Earth orbit, it's used for navigation right now. Leo is like closer to Earth, but coming to your internet only. So it's, we are talking about deep TV, Starlink, GPS, but right now we're talking about internet. So while connecting, if it's geo, it's just 3 satellites, but if it's coming nearer, it should have more satellites. Okay, which will increase your, again, cost and everything. So geo is a better option here. Geo in the sense geostationary Earth orbit. And coming to key players in satellite internet right now is the Starlink, OneWeb, and this one. Coming to a little difference we'll understand is the coverage even in the remote areas. As I was talking, for the rural areas, there's no way. So this can help over there. And this is only limited to terrestrial infrastructure. Wherever you have the infrastructure, it's good, great. Latency is higher in geo, lower in what's latency meaning? So if you message somebody, the time it reaches here, this time is called the latency. The latency is higher because it has from Here it has to go to the geo, that is geostationary orbit, and from there it has to come, right? It will take a very long time. But coming to your traditional things, it is just near the ground, so it will take very happy. So how to increase your speed with the Leo satellites? Because Leo satellites are nearer to Earth, but it's costlier because you'll have to have accommodate more satellites, so it's generally faster. Reliability is like, it's affected by weather and obstructions. It's okay in most conditions, but also in if there's huge floods or immediate landslides, then this is also not reliable. Setup cost is initially high, and this also it's expensive. Why are we trying to put satellite based communication or internet connection also is to make India more connective. That's it. Like remote areas, disaster risk covering, urban and suburban connectivity. Coming to applications, as I told, for rural areas and during emergency situations and the ships and airplanes where there will be no connection generally. And then coming to advantages is bridges the digital divide. As I told, some rural areas do not even have net right now. So in order to promote them to the digital world, this would help. Coming to challenges, it's highly costly and complex maintenance. Space debris for satellite constellations. What's space debris? So now these satellites will help you for a few years, but there will be an end to every being. Like that only, satellites will also work for some time only. After that, what happens? We will have to either repair it or we'll have to send new satellites. Then what happens to the old satellites? They'll sit there only. So that's called space debris. We'll see it in the space section. So right now, what can be our future? It can be like 5G is being there. It can be integrated with the satellite networks, as well as Leo constellations can be increased with the help of Starlink or OneWeb, where you can put more these things, satellites, and you can communicate. And maybe in future it could be affordable and latency can also be less. Thank you if you're till here. We'll see the class tomorrow. You'll get all the emerging technologies, connecting of the dots tomorrow, as well as you'll have a workbook of questions where you'll deal with all of these. So I have a question. If anybody of you are till here, I would love to ask you a question. So we know, I'll ask, so there's a word called facsimile transmission. I know many of you might think, some people might already know it. If you guys know it, comment in the comment section. And if you don't know it, just go Google it and see what is this. When you see it, you'll understand, oh, really? I never thought that the original name is this. Many of you might be familiar with this, but you're not familiar with the original name of it. So let's go Google it and comment down below.